Hey friends and digital marketers, this one's for you. I've got 30 seconds to tell you about Wix Studio, the web platform for agencies and enterprises. So here are a few things you can do in 30 seconds or less when you manage projects on Wix Studio. You can work in sync with your team on one canvas. You can reuse templates, widgets, and sections across sites. You can create a client kit for seamless handovers and leverage best-in-class SEO defaults across all your Wix sites. Time's up, but the list keeps going. Step into Wix Studio to see more. Hi, I'm Scott Hansel, and this is another episode of Hansel Minutes. Today I'm chatting with Andy Matuschak. He's an independent researcher who explores user interfaces that expand what people can think and do. How are you, sir?
I'm feeling good. I just wrapping up my normal workday, and my intellectual energies are drained and my social energies persist. I'm excited to chat.
Oh, I like that. Okay. It's good that your social energy is here. We'll get your intellectual energy back for the podcast.
We will try. We will try.
I appreciate that. Folks can check you out at andymatuschak.org, and they can learn about your current work as well as your previous work working at Apple and then also leading R&D at Khan Academy. Have you always been a person who has been thinking about how people learn, or did that get sparked at Khan Academy?
It got sparked actually during my time at Apple. I had a sort of unusual childhood education. I went to a strange school in St. Louis called Thomas Jefferson that has like 70 students. It's a middle and high school. And one of those places where we study Latin and Greek and the classics and very little math. And math problems aside, I was very moved by these sort of discussion and literature-centric experiences, particularly as I moved into a STEM world. And I think having a strange educational background made it top of mind for me. And then when I was at Apple, I became fascinated with the possibilities of dynamic media for us to understand things in new ways. At Apple, the design team would print out the entire operating system and put it on the wall so that we could see everything at once and try to make sure that everything's consistent. But what I found fascinating was that the most interesting design elements were the stuff you couldn't print. Things like inertial scrolling and rubber banding and the way that the parts of the system fit together in this kind of zooming user interface, favorite designs like the measurement app and so on and so forth. But I came to feel that all of these things were being somewhat wasted, I suppose, on, I guess, like polish and trivia rather than problems that felt very impactful. And so I became curious about how we might use dynamic media to do something really useful and valuable. And as I cast about for domains in which that might be relevant, education was top of mind. So I began prototyping and writing, and that's what drew the Khan Academy people to me and eventually to them.
You have a link directly on the homepage where you talk about why books don't work. And I'm visualizing this idea of like how you interact with books and how we interact with books. It's very linear. Like this is the thing, right? We live in a three-dimensional world. We move through four-dimensional space-time, and books are how I want you to read is linear on a single line, and in the chapters of the order that I want. I've always been impressed with books that start out in the introduction saying, read this book any order you want. Explore the book and come back later, as opposed to books that want this kind of intellectual striptease, for lack of a better and a more appropriate analogy. Do you find the linearity of books and online media to be irritating?
Well, one thing that's very interesting is that expert readers actually don't read linearly. And so we have these limitations of the medium, namely that not just print, but language is essentially linear. And this would seem to constrain the way that we read. But in practice, like an academic, a scholar, will typically read very non-linearly. A common thing to do is to begin with a table of contents, then to flip to the index, then to read parts of the preface, then to read the first and last paragraph of each chapter, then to read quickly all of a critical chapter or two, flip through, look at the figures, decide which parts to read further, and so on and so forth. Books don't make this terribly easy, but they do sort of support it. And so it's interesting to contemplate new media which support not only the kind of expert reading that I'm just describing, it's quite alien, I think, to most people. Most people seem to be surprised to hear that experts read in this way. But also, I guess, other more cognitively aware reflections on how it is that we effectively read and process information.
Someone might be listening and be mentally pushing back on the idea of an expert reader. Like, how do you know that someone is an expert? Are they an expert in their topic? Are they an expert at reading? Like, which angle are we coming at here? Am I an expert in my topic and I'm absorbing new information?
Sure. There's literature on this, and people slice it in different ways. So, like, one set of scholarship that I'm drawing on here is ethnographic, and so it's studying, the one I'm thinking of is particularly studying professors who are highly cited in their fields. So we're going to go ahead and observe the way that they read just environmentally. So we're going to be a fly on the wall, and we're going to watch what they do. We might say that they have both a great deal of domain expertise and also, as it happens, probably a great deal of skill in reading strategy. There's also a literature about reading strategy specifically, and kind of breaking down like people who might be an expert in their field but might not have reading strategies versus people who have reading strategies and aren't experts in their field. And you can kind of tease apart people who have one, not the other, will behave in slightly different ways. So earlier when I was talking about highly nonlinear reading, I think that's most common among people who have both domain expertise and reading strategy expertise. But people who have only reading strategy expertise are able to do things to comprehend complicated texts outside of their field, which people who are not familiar with reading strategies cannot do. So they will, for instance, try to make inferences actively across long distances in the text is like one behavior that's common. So, for instance, they'll try to draw this sentence here on the third page, strong connections between it and sentence on the first page. Like they had to introduce it this way because this connects X with the Y. And from this, they can kind of try to piece things together.
Okay, so then the irony, of course, that we're doing this in a linear podcast is not
right.
lost on me, because you also have a section in your essay on this about why lectures don't work, and
right.
One could argue that a podcast is a kind of a linear lecture, and it might be entertaining, but are we conveying information? I hope that over the last 900 episodes, people have gotten some value out of this that is more than just entertainment. Hopefully, it is edutaining at the very least. But is this an effective way to convey information at depth? Perhaps not. I hope that it is a place to kick off individual and personal explorations of topics.
Yeah, that sounds very plausible to me. So my criticism of lectures is that you talk about conveying information. And so I think usually when we think of information, we think about maybe you attend a physics lecture, and the physics lecture introduces the notion of torque. What is torque? How do we calculate it? What does it mean with respect to the cross product and the right-hand rule and all of these kind of very specific details. And so my claim is that a lecture is not a very effective way to cause somebody to acquire those kinds of understanding, these kinds of very specific pieces of information. But I do think both it and podcasts are effective ways for people to acquire different kinds of understanding, which are still quite valuable. We just might not call them information, although I guess from a computer science perspective, they still are. In particular, what I get from a podcast, for instance, is I get a portal into the way that Scott or his guest looks at a particular situation, looks at a problem, thinks about an opportunity. And that helps me build up a different kind of thing from something like a fact or a technical concept. It helps me build up these scenario templates, these kind of tacit knowledge things that you might get by hanging out at a great organization, where if I see something in the world, I might think, okay, this reminds me of this thing Scott said, or I might just be subtly and implicitly influenced in such a way that I kind of absorb the attitudes, values, behaviors, habits of people around me, both real and virtual, and those things collectively shape my behavior in the world.
The idea of those things shaping your behavior at depth is interesting to me, but I'm also noticed that a lot of folks right now are shortening their attention spans and the media that they consume so small that they'll grab a sentence and make that their whole belief system, as opposed to reading a book and absorbing the depth and the essence of that book and building their own belief systems. They can adopt them from a TikTok,
right?
Which is concerning.
Yeah. Here's maybe a charitable interpretation of that. Sometimes somebody can say a sentence, and the sentence seems banal. It seems like it can't possibly carry all kinds of information that's totally new to you. And yet, it seems to have a profound influence. So what is happening here? I think one theory, or one explanation of what's happening here is that sentence inspires a kind of process of reflection and a whole kind of internal cascade of deliberation. And from that, we now get some new conclusion, some new belief, some new way of looking at the world. And so it's not maybe exactly the sentence that carried all that information. The sentence tipped over a first domino, and the last domino is the one that we value.
Okay, so it's an idea catalyst.
Yeah, that's right. And I think like that can only happen if the situation is just right. And so much of the time, if the next person hears that sentence, the same thing is not going to happen. I do think that for what I was talking about earlier, trying to absorb a worldview, trying to absorb models, habits of mind, things like that, that the right way to approach that is kind of the opposite of the sentence form. It's where you try to basically build a full model of the way that the person is thinking, such that you could have had the same thoughts, the same conclusions. You could have found yourself uttering the same sentence, not just because you've memorized that one sentence, but because you've so thoroughly internalized that way of looking at the world that you can wear it like an article of clothing and become it.
Yeah. That's why I like that classic sci-fi word grok, to absorb
exactly.
information so completely that you eat it and it becomes part of you at the cellular level.
Yeah.
Interesting. Okay, so then popping back off the stack to the beginning there, where you were talking about animation and how animations were being used for triviality, the dynamism that was being used in the user interface was a nice little bit of polish, but it wasn't conveying information or expressing anything. Did you find that the hypermedia that the web represents, that I think even in 2024, we really haven't used it to the fullest? There's some really nice things happening with like D3JS, and the New York Times has some lovely infographics, but like scroll jacking on the web isn't enough to really be a good example of conveying information with motion and animation.
Right. Well, it's not really conveying information, I suppose. Like scroll jacking effects are their decoration, but we can contrast this with, say, complicated weather models that we may interact with, which allow us to view a huge amount of information very effectively. We can view information about different attributes of weather covering the entirety of the United States, and we can project it forward and backwards in time, and we can even perhaps get probability estimates. And all of this is built on computational models, which are themselves very complex and dynamic. As we think about hypertext and hypermedia, what does it do for us? In what sense is it dynamic? If dynamic media are media which can compute, can behave, can respond, then hypertext is a fairly narrow subset of dynamic media. Namely, it allows for navigation, rapid navigation, which we can construe as a kind of subsetting of an information space. So if you had the entirety of a book in front of you, hypertext allows you to rapidly focus your attention on a particular part of the book, narrow your field of view, and to do so in a targeted fashion. And so we found that works really well in situations where it's beneficial to rapidly shift your field of view in a targeted way. Encyclopedias, dictionaries, thesauri, things like that being great exemplars, because each of those targets are intentionally authored in such a way as to stand on their own. I think where hypermedia books, for instance, both fiction and nonfiction, have struggled to a greater degree is that one of the strengths of prose is the ability to use a narrative arc to construct a rich and elaborate context over time. As soon as you introduce hypermedia to the mix, you interfere with the prose's ability to do that, because any particular piece of the text is potentially something which people are going to reach through one of many different paths. And while that works fine for a thesaurus entry, which is short and independent, it doesn't work so well for page 200 of a 400-page delicate argument. And so there are structural reasons rather than merely cultural or technological reasons why we haven't seen richer uptake of hypertext, I think.
Okay. So then let me try to synthesize everything that you've said and the perspective that I've offered and apply it to some work that you worked on called Quantum Computing for the Very Curious, which you can see at quantum.country. It has scroll jacking. It has saving of your space. It has a timeline that shows you the time that you've interacted with the text. Help me understand, because this is a huge chunk of work here. It's a massive thing. I think you did this like 6 years ago. There's a huge amount of information here. What is different? How is this not just a really long book?
Quantum Computing for the Very Curious and the larger work containing it, Quantum Country, they are examples of dynamic media, but the hypertext parts are actually not very important or interesting. The part that's interesting is that it includes these interactive elements which try to support the reader's memory of the material. So for those who haven't seen, as you read through this book, there are embedded exercises where you might read for a few minutes, and then there's a few quick questions about what you just read. And that is not all that unusual. There's various online systems that work in this way. What is kind of unusual is that the book then follows up. And after a few days, it sends you an email and says, like, hey, we have empirical data which suggests that you probably started to forget some of this material that you just read. But if you spend like 5 minutes right now, you can remember it much more reliably into the future. And so on and so forth from there. And so the text is woven into this larger system, which tries to support your durable internalization of the material.
Yeah. And you call that a mnemonic medium. And the way that I've explained it to my teenagers was there's this Flappy Bird of the memory, and you learn something and then the Flappy Bird goes, and then you have to keep bouncing the Flappy Bird every couple of,
I love that image.
You like the spaced repetition of the Flappy Bird? You can use that.
Wow. Is it the case in the game? Does the bird's speed of descent change in response?
I don't think it does. I think it's fixed just based on their sense of physics. But I get the idea. My perspective is the harder you slap the bird, the longer it'll stay up in the air. So that works when you think about spaced repetition as well as trying to remember things.
Right. Yeah. The interesting thing about the spaced repetition thing is basically that if you are trying to recall what it is that you're trying to remember, when you can kind of just barely do it, then you will repeatedly extend the amount of time that you can remember. That is, the bird falls slower and slower each time. And sometimes we do this naturally, right? So I think it's interesting to ask the question, like, why is it that sometimes we read a book or we take a class and we actually remember the material, and often we don't? And we can explain the difference, I think, just in terms of the world conspiring to give us the correct flapping staccato rhythm. Sometimes we read a book, and then later that evening, it comes up over dinner. And then a few days later, it comes up in a project. And then a couple of weeks later, it comes up in a conversation after that. And each time it comes up and we can remember for longer. And that happens to just ride the bird at the right time. Whereas by contrast, if you read the book and it doesn't come up for a few weeks, then you try to remember and you can't remember, now you're not reinforcing it. So you look it up, but that actually doesn't reinforce your memory. So you can't remember any longer. And then it comes up a few weeks later and you still don't remember, and so on and so forth.
So my 18-year-old recently had to go and do a test because he's going to university in a couple of months, and they wanted to do a math placements test. He had done the majority of his math in sophomore year of high school, so he had 2 years where he hadn't done logarithms, he hadn't done pre-calc, and he was frustrated with himself that it took so long to dig those out of the archive. So we went to Khan, we banged out some videos, and then he dusted off, and he's like, "Oh, I remember the logarithms and how they work." But that distance, that 2 years was just too long. And then he started asking himself, why do I need to know this general knowledge? Like, this is stuff that's on the internet. Now when I was a kid learning geometry, my dad would always say, well, one day you're going to have to build a deck in your backyard and you'll need geometry. Like, that was a very 1980s perspective of why geometry is important. I'm struggling to explain to a teenager why these things matter, why base knowledge matters in a world where we might have AGI in a couple of years. What would you say to that? Right.
Well, I think this is a very difficult question, and it's one that we're all figuring out together. So let me try to address this as best I can from a pre-AGI perspective, and then
artificial general intelligence for those. Apologies for using the 3-letter acronym.
And then we can maybe consider a post-AGI world and ask about it. So why should a teenager care about logarithms when they haven't used logarithms in a couple of years? They're going off to college, and the entrance exam wants them to know about logarithms, and the same for polynomial facts and so on and so forth. And the best defense of this I can offer is that if you are interested in anything technical, really, then these topics end up underlying that technical material in a way where looking up the answer is actually not sufficient. And it's not sufficient for two important reasons. The first is that often it is not clear what knowledge you need but don't have in a given situation. So if you are trying to solve a difficult physical chemistry problem or physics problem or graphics programming problem, it may simply not occur to you that the situation you're looking at is essentially logarithmic, and that means that you can deal with it in terms of adding instead of some very complex thing that you're trying to approximate. More broadly, this applies in general, I think, to knowledge and creative work. Creative insights are very often the result of noticing a coincidence that seems a little suspicious, or noticing a contradiction, or noticing a connection. And I think it's only possible to notice those things in many cases if the constituents of the connection or the contradiction or the coincidence are both available to you. You don't know what you need to look up.
The idea of like, I don't know what I don't know. So where am I going to, I wouldn't even know what to Google for. I wouldn't even know, not even being able to ask the question. AI is not going to solve that problem.
Yeah. The second issue is one of fluency. And this one's really subtle and it's really hard to see and feel. So part of why my collaborator, Michael Nielsen, and I chose quantum computing for this project, Quantum Country, was that quantum computing is famously difficult. And we believe that one reason why quantum computing is famously difficult is that before you can do the first interesting thing with it, before you can look at the first interesting system, you are assaulted with this tidal wave of new notation and terminology and methodology and conceptual material. And then in order to look at the first meaningful quantum circuit, you got to combine these like 30 new ideas. And unfortunately, that's kind of physically not really possible in some sense. We have this working memory capacity that's very limited. You may have heard this phrase, the magical number 7 plus or minus 2. We can only hold so many things in our mind at once. And the way that we deal with complex material is by automaticity. That is, either we combine smaller things into a larger thing so that each one of those 7 slots goes further, or we've so thoroughly internalized something like moving a term from one side to the other side of an equation that it's not even something which takes up a slot anymore. It's simply something we can do automatically. And so coming back to the situation with your son, when many people struggle with college topics like physics, say, and it seems like the material is just really difficult, like this is just a really hard course. Actually, what's happening in many cases, I claim, is that the course is assuming they have a degree of fluency and automaticity that they don't have. And so they're like an old computer that didn't have enough RAM that's constantly paging out to disk and kind of like can't keep enough in memory at once to actually make progress on the problem before getting confused and lost and frustrated again.
That is a very good analogy. I have often used that term thrashing to disk. And no one remembers that a lot because we can't hear our hard drives anymore, which is something that I am mourning. I don't like a hard drive you can't hear spin. But when we were having this issue with logarithms, I suggested that we back up and we do some basic pre-algebra. And he found that irritating. I was like, no, let's just do it. It's literally a warm up before the heavy lift. And that worked and kind of dislodged what he needed to do. But there was a moment there where, like, it sounds silly, but like we're doing college level math here. And I'm like, let's just remind ourselves what PEDMES does. Let's remind ourselves of order operations. And it's like, no, I know all that. Do you though? Do you?
Yeah, so no, the problem is this word no. It's overloaded. I was working with a student last year on some pretty difficult physics. And they were having exactly the problem I was describing, where, I mean, it was undergraduate physics. It was first year undergraduate physics. And the material just felt really hard. They were trying to do problems and they were just struggling. And we thought, well, is it that they're forgetting the physics concepts that they're learning? And, maybe the spaced repetition thing will help. That wasn't quite it. Is it that they're like failing to comprehend material, so they remember it, but they don't really know what it means? Like maybe there's a bit of that going on. But actually it turned out that like in many cases, what was going on was that actually algebra just wasn't fluent enough for this person. That is, like, they needed to consciously use several of those working memory slots in order to do non-trivial manipulations of the equations in the problems they were solving. And so if half of your RAM is taken up by some old program and running in the background, then like you can't load the new program into memory. It's kind of was the situation. And so the proposed remedy, which I actually never got to see the resolution of, was like, okay, like maybe you need to get some fluency with algebra.
And that's a hard thing to hear.
Oh my gosh, yeah.
I was in Spain on a job recently, having taken 5 years of Spanish and feeling like I was quite competent in Spanish, only to discover that my Chipotle level Spanish was not going to cut it in Spain. And it was a moment there where I was like, wow, 5 years of Spanish, and I probably speak at a Spanish 2 level. And that was a real reset. I need to go back to school, no joke, and get a tutor and just tighten up that base of the pyramid of my knowledge before I try to go back to Spain.
Yeah, we use this word know to mean am familiar with, and if you like remind me, I can kind of page it back into memory, or like I can with effort produce that material, or I know it like the back of my hand. And like from a mechanical perspective, cognitively, those all mean really different things and are going to give rise to really different results in a given situation.
Yeah,
as you're experiencing.
Yeah, and I've absolutely, and I'm watching that with a great deal of parental empathy as I watch my sons explore this stuff. A couple of 2 shows ago, I had Sam Rose on the show. I'm not sure if you're familiar with his work.
Yeah,
Sam does some amazing work with visual introductions to computer science, which I think really blurs that line between a truly interactive computer program and an interactive book, where he gives you a couple paragraphs. And then he just hits you hard with a really great visualization that clarifies it. And we talked about on that episode whether or not he believed in learning styles. I believe very much that I'm a visual learner, but then I hear that there's research that says learning styles is not a thing. There's no such thing as an auditory learner or a visual learner. Where do you stand on that argument?
Yeah. So there's like an empirical question. The empirical question that you're referencing is like, we used to think that maybe it's the case that like Sally is a visual learner and Bob is a symbolic learner. And so it's very important that you like present visual material to Sally and symbolic material to Bob. And we thought that maybe those things are like traits of the person as opposed to states, or maybe they're partially traitish. And that seems not really to be true. But there are some things that are sort of like that are true. One is that we have different fluencies in different media. And so as we're constructing understandings of a new topic, a person who is very visually fluent, that is, has a large repertoire of patterns that they can draw on, when they're presented with information about that new topic, they will tend to use that repertoire to construct visualizations in their mind. They're elaborating what they're hearing and they're connecting it and comparing it to prior related topics. And they're using visual apparatus to do that. And somebody else who's maybe more abstract or symbolic might take in a topic and be digesting it internally with abstraction. And it's true that for those people in that state that they're in, given their background and their fluency with those different topics, somebody who has that visual repertoire, if you present them something visual, it may be easier for them to draw on their visual repertoire. It's not exclusive, though. Like, you can have both the visual and the abstract repertoire. It's more just a question of experience. And I think like the thing that relates to this, and it kind of cuts through the idea of the either or, is that you will, in roughly all situations, understand the thing much better if you can represent it in many ways. So actually, it's better for you to learn it visually and symbolically and narratively and so on and so forth, kinesthetically, insofar as it's possible, and then to form connections between all of those representations. Even if you don't have deep repertoires, in all of those things. Basically, the more representations that you have of the material, the stronger the understanding that you will construct. And that, I think, is more important than the individual differences and backgrounds.
One thing that I think you've also taught me and added to the discourse is an essay that you wrote on your ideal learning environment, where you were talking about what was happening around in your life during a moment when you learned a lot. You noticed that to tell people about a time when they learned a lot, but learning wasn't the point. Like you felt like you grew, but it wasn't because you went off in a moment to learn. And I think right now we are structuring school for kids where it's like, all right, it's 3:00, learn, you know, and that's very difficult. And that's not typically the time when they feel like they are learning the most. How do we make space for the learning to happen more naturally as opposed to compartmentalizing it into you must learn now from 9 to 4?
Right. One of my favorite places to draw on for this is Reddit. Reddit is the home of so many obsessives in so many very strange niches. And you can go and find the person who has gone so far down the rabbit hole of like a woodworking tool from the 18th century that they're now a master of. And like often these people are teenagers. So there's that old trope about like the teenager knows all 150 Pokemon or, the first 150 Pokemon, but they don't know, the first 5 elements of the periodic table. And they seem to struggle with the latter and not the former. And why is that? And the former is embedded in something with social meaning for them and the latter is not. And so I'm very excited about a future wherein the learning that we do is increasingly of that kind, like the Pokemon or like the 18th century woodworking, where we're learning things that are connected with interests and projects that really matter to us.
Yeah. It is frustrating, though, that I also had zero effort and zero trouble remembering all those Pokemon. It took Pokemon Go and, my kids to run around. We went on walks and we collected everything. And I guess now there's 1,025 Pokemon. I don't know why I know that. And
really? Oh my gosh.
Yeah, there's a lot of Pokemon now, and then knowing all, but like, if you've got we're saying that we're saying as parents, you have the storage and the capability to connect these and their evolutions, and you can't remember, this mnemonic from math class or whatever. And it comes down to the reward structure for these things. Also, the simple fact of saying you got to learn that is almost enough to turn them off completely.
Sure. And one thing that's often a little bit obscured in these conversations is when we think about the Pokemon versus the periodic table or whatever, it's often phrased like a choice. Like, okay, like you chose to remember the 150 Pokemon, but you're choosing not to remember the elements of the periodic table. And I mean, perhaps there's an element of that, like maybe they're making a choice about how they're spending their after school time or whatever. But I think even if you were actually to hold exposure constant, like they are in the chemistry classroom for N hours per week, and it's like pretty significant, like there's dozens of hours, and yet still like maybe not that much is being remembered. And so I think quite apart from the element of choice, we can see all kinds of other effects going on. If you're to hold constant the time exposure for the periodic table of elements and the Pokemon, I think you'd see that the Pokemon still get remembered more because it's much richer networks of connection, that the Pokemon are connected to the episodic experience the person had playing the game. They're connected to that conversation they had with a friend where you were arguing about whether Charmander or Bulbasaur was better in a particular situation. They're connected with the visual expression of the Pokemon, which have their own kind of mnemonic characteristics to them. They're connected with a song. It has its own internal connections. They're connected to a culture and like a set of visual expressions and memes. There's incredibly rich stuff happening in one place that's either not happening or it just isn't being attended to, isn't deemed interesting in the other place.
Yeah, which arguably then makes your point from the middle of the podcast about those are the things that we need. That is, we need all of the different representations of the knowledge in symbolic, kinesthetic, et cetera, and then spaced repetition in order to really make it a part of who you are and hold on to it for as long as possible.
Yeah, I guess my claim is that like if there is a visceral reason for the teenager or me, say, to know the first 100 elements of the periodic table and to know all of their properties fluently, then I believe we will cause that to happen for ourselves. And we can talk about making it happen more effectively and efficiently, whatever. But I think the key issue actually is that reason doesn't quite exist.
Mm. Well, you are creating tools for thought at Patreon/Quantum Country. You've got almost 1,500 people that are supporting you in the work that you're doing there. Lots and lots of great and interesting content there. You can also check out andymatuschak.org to learn all about your independent research, some really great notes, some free essays, information about how you learn your own daily routine. Just a wealth of information. I appreciate you so much for coming on the show and hanging out with me today.
And thanks so much for a great conversation, Scott. This is really fun.
I wish we had even more time. This could be a whole series, but we could hear more from you by going to your Patreon and supporting you and checking out your own essays and podcasts. This has been another episode of Hansel Minutes, and we'll see you again next week.